Welcome guys in MechTrotip. In this video I will explain you instantaneous center method, which is one of the velocity analysis methods and mechanisms. In this video I will explain you what exactly instantaneous center is. Then we'll see Kennedy's theorem and we'll see a simple basic problem based on slider crank mechanism with great fundamental details. So first of all, let us understand that what is the meaning of this instantaneous center. What is that actually? So to understand this, consider a plane surface, any plane surface. And on that plane surface, any arbitrary shaped body is placed. And on this body, consider any 2 points, let us say point A and point B. This body is freely placed on the plane surface. When I apply some magnitude of force to this body, it changes its position. Let us say I apply some force let us say in this direction on this body. So let us say this body takes position in somewhat. Let us say it takes this position, new position. Let us say this is new position of A and this is new position of B. We see that in a journey of body from this position to this position, this body has not only translated from here to here, but also has rotated. And in this type of motion, analysis becomes difficult. The motion, if it has only one motion, say it's rotational motion, the analysis becomes easy. And if we make a slow motion video of motion of body from here to here, we see that at a particular instant body has taken this position, body has taken this position at a particular instant, and finally body takes this final position. We see that point on bodies are moving in different directions. We can here see that point A is moving in somewhere in this direction, point B is moving in somewhat in this direction. And we can have only one type of motion, but it would be at a particular instant. This body position is at particular instant, this body position is at particular instant. If we are talking about this instant position, then we can have only rotational motion, and the center of that would be normal to this velocity vector and normal to this velocity vector. Wherever they intersect, this is I center, which means body's instantaneous center of rotation, body is in purely rotation about that instant, about this point. Now let us take a special case. With same body, same points A and B, and we have bounded this body with a sliding pair, which means whatever force you apply, the body is going to move only in that particular direction. In this example, it is going to move only in horizontal direction. So whatever push you apply, point A is going to move in horizontal direction and B also in horizontal direction. So in this case, if we draw a normal to point A and similarly at point B, we see that both of them are parallel, and it is assumed that they are meeting at infinity, which means the body's I center is at infinity. Now let us see one important theorem which is used to locate instantaneous centers of a mechanism, of complex mechanisms, which simply says that if three plane bodies have relative motion among themselves, their I centers must lie on a straight line. A very good example which I can give you to understand this theorem is of two gears in mesh. One is smaller gear, one is larger gear. Let us say this is body 2, this is body 3, and they are fixed to a frame, particular frame, which is body 1. This is also body 1. Since this gear 3 is moving in purely rotational motion about this point, so this is I13. I13 basically means that body 3 is in purely rotational motion about this point. Similarly, this is I12. And if we join both of them, there are three possibilities. One is I12, I23 and I13. I12 and I13 we have got. Theorem simply says that I23 is going to be somewhere on this line. And we know that this point, which is known as pitch point, at this point both the gears have same velocity, and so in this case this would be I23 point. At this point both the gears will have same velocity, and that's why we use simply the relation like V23 at 2 is equal to V23 at 3. That's the reason we use R2 omega 2, R3 omega 3, where R is simply radius and omega is angular velocity. To prove the Kennedy's theorem, I'm not going to use the methods given in books, in which what they do is they consider the opposite of what Kennedy's theorem tells, and finally they say that our consideration is wrong, and that's why Kennedy's theorem is true, that all the instantaneous lie on the same line. We'll not use that method because that method creates a lot of confusion for some people. What we'll do is we'll consider a 4-bar chain. Consider this 4-bar chain. This is point 1, link 1, link 2, link 3, link 4, and this is again link 1. This is I12, this is I23, I34, I14. I have observed many people that they don't know exactly what is the meaning of this all I centers. I12 simply means that body 2 is in purely rotational motion about this point. It is not necessary that it should be at a particular instant only. It can be for a long time also. It should be at least for that instant. I23 simply means that this is the center of pure rotation of link 3 when body 2 is fixed. Similarly, I34 means link 4 will have pure rotational motion about this point when link 3 is fixed, and I14 means link 4 will have pure rotational motion when link 1 is fixed, which is fixed in this mechanism. Let me give you an information about number of ICs formula, which is equal to NC2, N combination 2, where this N is number of links in mechanism. In this mechanism we have 4 links, so it is equal to 4C2, which is equal to 6. And what are that 6 ICs? We have one link 1, 2, 3, 4. So I12, I23, I34, I14. What new combinations can be? I13 we don't have here, so I13, then I24. These all are possible combinations. Now suppose if we want to find I13, so link 3 is here, and this point is common for link 2 and link 3. Similarly, this point is common to link 3 and link 4. As the theorem says, if 3 bodies have relative motion, so what we do is we first consider relative motion between link 1, link 2 and link 3, only this much. three bodies. We know that link 2 is in pure rotation about this point. So motion of this velocity would be in this direction or in this direction, perpendicular, but perpendicular to link 2. So for body 3 also the same would be the direction. So what we do is we draw perpendicular to this point, the velocity vector. If we are talking about relative motion between link 1, 4 and 3, these much three bodies, we know that link 4 is in pure rotation about this point. So velocity will be either in this direction or in that direction. So what we do is, but this point is common also at link 3. So what we do is we draw a perpendicular to the velocity vector. We see that both of these lines intersect at some point. We name it as I13, which is instantaneous center of link 3 at which is center of rotation of link 3 at that instant of time. So in this way we have proved Kennedy's theorem that if three bodies have relative motion among themselves, then their ICs lie on straight line. This is a straight line. Similarly, if 1, 4 and 3 are in relative motion, then these are the three ICs in a straight line. Now if one wants to locate I24, I24 simply means that point at which link 2 would be in pure rotation at that instant when link 4 is fixed, or vice versa. That is, link 4 will have pure rotary motion at that instant when link 2 is fixed. So the method which I show you here to locate, if we do with that method, then I think task would be difficult. So what simple method we use is, we draw a simple circle. We have 4 links, so we mark 4 points. 1, 2, 3, 4. We have I2, we have I1 to I2, 3, I3, 4 and I1, 4 already. If we want to locate I24, what is the shortest path of going from 2 to 4? That is 2 to 3, 3 to 4. 2, 3 is here, 3, 4 is here. So extend this line. What is another path of going from 2 to 4, which is 2 to 1, 1 to 4, or 1 to 1, 4. 1, 2 is here, 1, 4 is here. Wherever both the lines intersect, that would be I24. Now let us see one basic example of slider crank mechanism, in which generally we are asked to find velocity of slider and we are given with all the dimensions of links. So according to number of ICs formula, we have again NC2 and N is 4 links, 4C2, which comes to be equal to 6. And what are the 6 ICs? We have 4 links, so what combinations we can have? I12, then I13, then I14, I23, I24, then we can have I34. These are the combinations which we can have. So we already have I12, we have I23, we have I34 here, and we also have I14. Since this is a sliding pair, as I showed you in starting of video, that if it is sliding pair, then its I center lie at infinity. So I14 at infinity. Draw parallel to this line at hinge also, I14 at infinity. And many people don't know reason that why do we actually draw this line here. Slider is here, so why do we draw this line here also? So to understand it, I want to tell you in advance that this line actually is going to help us in locating I24. And I24 simply means that at I24 the link 2 will have pure rotational motion at that instant when link 4 is fixed, or link 4 will have pure rotational motion at that center I24 when link 2 is fixed at that instant. So let us say in this mechanism, if we have link 4 is fixed instead of link 1, let me draw. Here is slider. This is link 1, 2, 3, and this is link 4, and slider is fixed. So in this case, this is I12, this is I23, this is I34, and in this case, this link 1, if you see inversion, fourth inversion, you see that it is hand pump and link 1 is sliding, which means this point will have direction of motion in this way, horizontal, and link 3 has a pure rotation about this point, so it would be perpendicular to link 3 either in this direction or in this direction. So if we want to locate I24 in this case, so both the points lie on link 2, this and this, both the points lie on link 2. So if we want to locate I24, what we do is we draw perpendicular to this velocity vector. Similarly, we draw perpendicular to this velocity vector. This is I24. So if we are talking about three links, link 2, 3 and 4, then we have all three I centers in one line, I24, I23 and I34. But if we are talking about link 1, 2 and 4, then we have only 1, 2 and 2, 4. Which means one more is remaining, 1, 4 is remaining. So we say that 1, 4 is on this line. Where exactly we don't know. So I14 at infinity. That is the reason why we say that I14 at infinity here also. Because here, irrespective of which link is fixed, we are locating all the ICs. So now let us come back to our problem. In this type of problem, we are generally given with all the dimensions and omega of link 2. So we can easily find the velocity of 0.23, which is equal to V23 is equal to radius of this link into omega, which is I12 to I23 is the radius, into omega of link 2, which we can now easily calculate. This type of problem where we are asked to find velocity of slider, which is V34, which we need to find, and in this mechanism link 1 is fixed, so we don't need to locate V24, because in this mechanism we don't have link 2 or link 4 fixed. We have to find ICs which are associated with link 1 only. So here we need to locate I13, which we can easily locate. I showed you two methods, either you can use any one. So we will find that I13 gets located here, and this point simply means that about this point you can use same value of omega 3 throughout the link. We have velocity of V23 and we need to find V34. What is velocity? Velocity is r omega. So what omega would be? V by r. So if we are talking about omega 3, it would be equal to V23 divided by this much I center to that point distance, I13 to I23. Similarly, it would also be equal to V34, which we need to find, divided by I13 to I34 distance. We have calculated V23. We can measure I13 to I23 distance. We can also measure I13 to I34 distance. So in this way we can find only unknown as V34. We can find I34, which is velocity of slider. I hope this video was beneficial for you. So like the video and don't forget to subscribe and support our channel. Thanks for watching.